Hello everyone. Alright, today we're going to continue on Unit 2 and we're going to be talking about title blocks. Now these are one of the most important aspects of a blueprint or an assembly drawing or anything like that, as it tells you what it's going to be made out of, what its part number is, who designed the part, where is it going to, what you need, and everything. So if you go to Unit 2, page 29 in your book, you will get this title block. And we're going to go over it piece by piece. Another page that you're going to need is Unit 1, page 10 and 11. Those are your abbreviations. Those are the ones that are like DWG, which we'll be going over and what they're actually meaning. So, the first thing is we look at this title block, has a lot of information on it. First thing is, who is it going to? Who owns this? And that would be the Great Dane trailer is incorporated in Savannah, Georgia. So if you were talking about where this needs to be shipped to or who the customer is, that's who it goes to. The next thing is, what is this part? For them, you go to your title. That is what the part name is. But a lot of times, you might not have a name, you might have a number. That's where you get DWG, NO. DWG means drawing, NO means number. So this one, its drawing number is 040-47315. If you were like in your computer looking it up, trying to figure out what it is, you can type that in, done. The next thing is right next to it. Revision A, REV. Now, when you look over here, you got reverse, revision, and revolution. For this one, it's going to be revision, and that could be, say, revision A, it could be revision 1, it could be revision 14-5. If you look at stuff like Windows 7, Windows 10, Windows, say they get to Windows 14, what that means is this is the 7th, 10th, this is the 14th. For this one, this is revision A, so it's the first drawing of it. If they have to go in there and later on just update a piece because it's not quite working right, or say that the hole inside of the piece needs to be bigger, maybe they have to change out what material it's made out of. They'll just revise it, and if you're working on it, they want you to be up on the most current revision of it. So then we go to the middle part of this. This was signed off by, this says JR, and it was released on 12/7/2000. So that tells you when it was released, when it was approved and sent out. The next thing is your scale. This says a 1:2 scale. So if you're looking at your blueprint and it was 1 inch across, like if you actually measured it with a paper or with a ruler or something, it means in real life it'd be 2 inches. So it's a scale of 1 to 2. Sometimes it's like a scale of 1 to 30. Sometimes it might not have scale on there because it's like this is the blueprint to a AC unit and it's huge. So sometimes the scale's not on there, but that's what it means. It is a 1 to 2 scale. On there it has 1-2. Sometimes they will do it with 2 dots. So if I was to do it down here, a 1 to 2. Either way is right. The next one is DWN, or drawn. Who it was drawn by, who was the engineer who made it, and that'd be Scott R. The next one is the date. This is when Scott finished it. He finished it on 12-2-2000. Used on is typically different. That's one of those where you might have to sign it off yourself, or the last time somebody used it or something like that. That's one of those where it kind of gets used in different ways. So when we look over here, we have unless otherwise specified, and then these are your tolerances. Remember when I said that a tolerance and an allowance are 2 different things. So remember that. So let's first look at our tolerance. On tolerance, we're working on dimensions or in inches. So it's telling you it's in inches. So they're not going to do any dashes. They're not going to put next to it INCHES. They're not going to do any of that. They're just going to put 0.50 or 0.500, half an inch. So that's why it's important to know what are my dimensions. What are they doing it in? If it said dimensions are in metric, then you know we're doing it in millimeters or centimeters and stuff like that. So, tolerance on decimals. We have 2 place and 3 place. Those are your two most common, it's 2 place, 3 place. So if we're working, for whatever reason we're working with 0.50, that's a 2 place. If they say 0.50, that means these are now your tolerances for it. If it says 0.500, you're working with a 3 place, now we're working with those tolerances. So it's always important to know, if it says this, we're showing you this many decimals, which bracket are you falling under? Now if it says plus or minus 0.010 or 0.01 for everything, then you know. But that's the biggest thing, and that's where another thing we need to look at is what is a plus and minus symbol. Plus or minus, what it means is if I say 0.500, and it's under 6 inches, that means it can be as small as 0.495 or as big as 0.505. As long as it's within those brackets, in that range, you're good. So that's tolerance. So, we look over here, and it says from 0 to 6 inches, decimal inches, what are we looking at? What are we wanting? So if as long as it's half inch, inch and a quarter, 5 inches and 63, 64. So I know that's fractions and not decimals. But let's say we get all the way up there. It still fits in there. In fact, 6 inches still fits within this range. The next one is if it's 6 inches, or if it's over 6 inches, so 6.001, up to 24 inches, or 2 feet, we're within these. That's important to know because if they're giving you 0.01 tolerance over 2 feet, then it means you get a little bit more leeway compared to 0.005. If you're over 24 inches, so 2 feet and beyond, so if it's 18 feet long, you still only have a playroom of either 0.06 or 0.015. So that is important to know. It doesn't just keep scaling up. They say if it's over 24 inches, that's it. That's your tolerance. The next thing is our angles. Plus or minus half a degree. So if something is supposed to be 90 degrees and it's 89 and a half or 90 and a half, you're perfectly fine. You're within your tolerance. But if it's 90 and 3/4 of a degree, too much. Next, we're going to look at material. Now, material, it says 5052-H34AL. In your book, it says ALUM. I'll get back to that in just a second. Why is this important? For those who work with metal, there isn't just one type of aluminum. Just like there's more than one type of stainless steel, one type of carbon steel, cast iron has different grades, copper can have different grades. If you think about it, if you were making something out of wood, it matters if you're using something like mahogany, oak, or pine. Metal has a very similar property where certain metals are differently treated. They have different crystal structures and stuff like that. So it's very important that if it says use this type of aluminum, you use that type of aluminum. For those who do weld, the reason why this is so important, if you are making a weld and you use a certain rod meant for a certain piece of metal, and they use the wrong metal, it could not fuse together. For the people who are machinists, You know that certain metals fail at different rates. Certain steels are actually stronger if they have like chrome moly or nickel or stuff like that in them compared to just mild carbon steel. So that's why it's important that you follow what it says so that everybody else down the line works with you. The next thing, how much does it weigh? 2.11 pounds. This is important for shipping. If you're working in shipping and this thing is supposed to weigh 2.11 pounds and it weighs 8 pounds for just one of them, there's a problem. Why does it weigh so much? If it's made out of aluminum and it weighs 2.11 pounds, awesome. If it's made out of steel, it could weigh 8, 10 pounds because of the difference of metal. So that is why it's important. Of course, if you've ever done anything with like shipping, trucking, or stuff like that, you know that weight is very particular. An 18-wheeler, somebody who's using a truck or something like that, and they're going down, they get to a weigh station. If it does not match up what they're saying, they can get into a lot of trouble. That's why it's important. What you do affects other people down the line, just like the people before you will affect how you do stuff. So always do that, always check yourself. Next thing, this says sheet 1 of 1. So if this says sheet 1 of 20, that means you would have 20 papers showing you the assembly drawing. Now it might be multiple different parts and stuff like that that go to one grand piece. But this one says 1 of 1, which means you'll get one sheet of paper, and it'll show you all of it, has all this, might have a part list, and that's it. If you get something that says sheet 1 of 3, and you have one paper, you should be looking for the other 2. Because they might have other things on there that tell you, hey, when you're done, make sure you spray paint it black. Make sure that you grind this one part down. Make sure that you flip it over and you weld it in the back side, or maybe you have to machine a hole into it. Maybe if you're working with actual duct tape, you got to duct it in the back to protect it from being shipping or something like that. So there's other stuff that can be done with it. So we were going over DIME or DIM, which means dimension. If I went up here and I see it right here, that means my dimension. I see INCL, included, or include. Another one, I said I'd get back to this, MATL, which means material. Another substitute for that is MTL. So just know that there's 2 abbreviations for that. Sometimes a non-standard abbreviation is MAT. So that's still material, and that's where you kind of have to look at it and just know, what is it referencing? If it said MAT, which is not standard, but it told you 5052-H32 aluminum, you know that that's your material. The next thing, we look at aluminum. AL. Another one is ALU. In that drawing, if you actually look at it, it says ALUM. If you have a question about something because they're not using standard abbreviation, always ask your engineer. Ask the person who's in charge, hey, what does this abbreviation mean? It's not standard, or I don't know what this one means. It's okay to ask people that. So if I see AL, ALU, or ALUM, it's aluminum. I don't know what it is. I ask whoever's in charge. Maybe you're a supervisor. And you're like, hey, I don't know what this means. Can you help me out? And they go, yeah, what's your drawing number? You tell them it's 040-47315, revision A. They might ask you what the title is, just to double check. You tell them and they come back, oh, it means aluminum. Like, thank you very much. You go on. So that is what a title block is. That's why it's so important. All it does is check and balances, make sure that you're doing the right thing and that the people who are before you and after you are okay. So, read up on it, double check on title blocks, and I hope you have a good day.